Welcome to today's paper reading. Today's paper is titled, Automated Unit Test Improvement Using Large Language Models at Meta. This paper, authored by Nadia, Alshahwan and colleagues from Meta Platforms Incorporated, presents the TestGen-LLM tool, which leverages large language models to enhance unit tests. The study was published in the Proceedings of the 32nd ACM Symposium on the Foundations of Software Engineering. This paper introduces Meta's TestGen-LLM tool, which leverages large language models, LLMs, to automatically enhance existing human-written tests. The tool ensures that its generated test classes meet a set of filters, guaranteeing measurable improvement over the original test suite and mitigating issues related to LLM hallucination. The deployment of TestGen-LLM was evaluated during Meta's testathons for Instagram and Facebook platforms. For the Reels and Stories products on Instagram, 75% of the test cases generated by TestGen-LLM were successfully built, 57% passed reliably, and 25% increased test coverage. During the testathons, the tool improved 11.5% of the classes it was applied to, with 73% of its recommendations being adopted for production deployment by Meta's software engineers. This paper marks the first report on the industrial-scale deployment of LLM-generated code with such assurances of code improvement. This research focuses on improving unit testing through automated methods. Key techniques include automated test generation, leveraging large language models, LLMs, and genetic improvement. The study is conducted at Meta and will be presented at the 32nd ACM Symposium on the Foundations of Software Engineering in November 2024. The authors are listed in alphabetical order, with Mark Harman as the corresponding author. The publication rights are licensed to ACM. TestGen-LLM is an automated tool developed to enhance unit test generation for Android code. It employs two of Meta's large language models, LLMs, to extend existing Kotlin test classes by generating additional test cases that cover previously missed corner cases and increase overall test coverage. This tool exemplifies assured offline LLM-based software engineering, assured offline LLMs, embedding language models into a larger software engineering workflow to recommend fully formed software improvements with verifiable guarantees. TestGen-LLM has two primary use cases: evaluation to assess the impact of different LLMs, prompting strategies, and hyperparameters on code improvements, and deployment to automate test class improvement, producing code recommendations backed by guarantees. The tool includes a filtration process to discard non-guaranteed test cases and uses telemetry for performance evaluation. The TestGen-LLM system employs a series of semantic filters to ensure the quality of candidate solutions generated by language models. The first filter ensures that the code is buildable, discarding any that fails this check. The second filter requires that tests pass on their first execution to be considered for regression testing. To further ensure reliability, the system uses repeated execution to filter out flaky tests, requiring a test to pass 5 times consecutively. Additionally, the final filter measures coverage improvement, discarding tests that do not enhance coverage. The advantages of this approach include measurable improvements in code coverage, verifiable guarantees against regression, and an ensemble approach that leverages the strengths of multiple language models. Figure 1 illustrates the architecture of TestGen-LLM, a system designed to improve unit test classes using large language models, LLMs. The system employs a 3-filter approach to ensure the quality of generated test cases. The first filter checks if the candidate code can be built within the existing infrastructure. The second filter executes the tests to ensure they pass reliably, discarding any that fail. The third filter measures the coverage improvement of the passing tests, retaining only those that enhance coverage. The architecture also includes pre-processing to extract test cases and post-processing to reconstruct test classes, ensuring that the final output is a reliably improved test class suitable for regression testing. The deployment of TestGen-LLM at Meta followed a structured process starting with an initial trial. During this trial, 8 diffs were created using an early version of TestGen-LLM and submitted to Meta's continuous integration system. This trial highlighted the need for individual test case guarantees and the importance of providing detailed coverage information. Following this, the tool was used in the Instagram Testathon in November 2023, where 36 engineers participated, generating 105 diffs, 16 of which were by TestGen-LLM. This phase also introduced the concept of diff time deployment, which was found to be more effective. Before full deployment, an evaluation of different language models and prompts was conducted to determine the most effective settings. Based on these evaluations, default settings were chosen for wider deployment, which was then fully automated in subsequent testathons. Table 1 presents the outcomes of the first Instagram testathon held in November 2023. The table lists the top 10 performers based on the number of tests generated, lines of code covered, and the number of diffs submitted. TestGen-LLM, the automated tool, secured the 6th position with 17 tests generated, covering 1,460 lines of code across 17 diffs. Each diff contained exactly one test case, showcasing the tool's efficiency in extending existing test classes with additional test cases. This approach allowed for easier acceptance or rejection of recommendations by engineers, contributing to its competitive performance relative to human engineers. Figure 2 presents a Sankey diagram illustrating the filtration process outcomes from an experimental study on Instagram components for Reels and Stories products. The study utilized 4 prompt strategies from Table 2 and 2 language models, LLM1 and LLM2. Key findings include 75% of test classes had at least one new test case that builds correctly, 57% had at least one test case that builds and passes reliably, and 25% had a test case that builds, passes, and increases line coverage compared to other test classes with the same build target. Table 2 outlines the 4 primary prompts utilized during the December 2023 Instagram and Facebook app testathons. These prompts, namely extend_test, extend_coverage, corner_cases, and statement_to_complete, each serve a distinct purpose in enhancing test coverage. For instance, the extend_coverage prompt directs the language model to write additional unit tests that increase the coverage of the class under test. Similarly, the corner_cases prompt is designed to focus on covering corner cases missed by the original tests. This table provides a clear view of the strategies employed to maximize the effectiveness of automated unit testing using large language models. The deployment involved a total of 8,996 trials on Instagram and 23,535 trials on Facebook, with success rates of 0.05 and 0.04 respectively. TestGen-LLM was applied to 1,979 test classes, successfully improving 196 of them, with 73% of these improvements being accepted by developers. Regarding temperature settings, the default setting of 0.0 received the most trials, 30,483, but a success rate of 0.03 was observed for temperature 0.4. It's important to note that interpretation of these results requires caution due to varying sample sizes and deployment conditions. Table 3 presents the results of test case generation trials on 2 platforms, Facebook and Instagram. The data indicates that while the total number of trials was higher for Instagram, the success rate was slightly higher for Facebook. This discrepancy is hypothesized to be due to the availability of more human-written test cases for Facebook, which is approximately 10 times greater than that for Instagram. The table highlights the importance of training data and influencing the success of automated test case generation. Table 4 presents the results of different temperature settings and language model performance. The default setting of 0.0 received the highest number of trials, totaling 30,483. Interestingly, a temperature setting of 0.4 also demonstrated favorable outcomes. The logarithmic nature of coverage growth is highlighted, indicating that as more coverage is achieved, it becomes increasingly difficult to further improve coverage. Table 5 presents the results for the 2 different language models, LLM1 and LLM2. LLM2 was chosen as the default model after initial execution, leading to a significantly higher number of overall trials at 28,654. LLM1, on the other hand, had 163 successful trials. The success rates for LLM-1 and LLM-2 were 0.05 and 0.04, respectively, indicating a slight performance difference between the two models. Table 6 presents the performance results of two different large language models, LLMs, across two platforms, Facebook and Instagram. The data reveals that the Facebook platform enjoys a higher success rate compared to Instagram. Specifically, LLM-1 achieves a success rate of 0.07 on Facebook, while LLM-2 records a lower success rate of 0.03 on Instagram. These figures underscore the platform-specific performance variations among the LLMs, highlighting the importance of platform characteristics in interpreting LLM performance. In this section, the authors present qualitative observations from the deployment of TestGen-LLM. One key observation is LLM self-plagiarism, where the same or similar responses are generated for the same prompt due to the deterministic nature of the default temperature setting. This led to the implementation of a filter to remove previously seen test cases. Another observation is the nuanced coverage reporting, where valuable additional coverage is obtained, sometimes indicating inadequate mocking. This issue is flagged to code reviewers for awareness. The authors also highlight the need for tests, noting that generated tests with to-do can indicate potential coverage wins and serve as useful hints for human test writers. In the field of large language model-based software engineering, LLMs, software test generation is a widely studied topic. Previous surveys, such as those by Wang et al. And Fan et al., confirmed the prevalence of LLM-based test generation. However, no prior work has addressed the problem of extending existing test classes or provided measurable assurances for improvements and absence of regressions. This paper introduces a test extension application as part of Assured LLMs and reports its deployment at Meta, marking the first industrial application of Assured LLMs. Coverage results in the literature vary widely. For instance, Siddiq et al. Reported 80% coverage on the human eval dataset but only 2% on EvoSuite SF110. Schaefer et al. Also reported high coverage but for smaller systems. Our findings are consistent with results on larger open-source systems, with approximately 57% of Kotlin test cases being executable. TestGen-LLM combines traditional software engineering with language models, filtering candidates to prevent hallucinations and suboptimal results. It also uses an ensemble of language models, inspired by genetic improvement and automated repair, but differs by using language models instead of genetic programming. The future work in this area focuses on three main open problems. Firstly, assessing improvement in automated test generation. While line coverage is currently used as a proxy, it has limitations. In experimental conditions, the success rate is 25% under strict criteria and 57% when relaxed. Future research will explore other criteria, such as mutation coverage, which has shown better performance but is computationally demanding. Secondly, the resolution of probability distributions from language models. These models produce conditional probability distributions that are typically resolved using search algorithms with a temperature parameter. More research is needed to develop application-specific techniques for this transformation. Lastly, the issue of language models mimicking existing coding styles. This fashion-following behavior is both beneficial and challenging. It allows the models to faithfully replicate existing styles, which has received positive feedback, but it can also perpetuate deprecated coding habits. Future work will aim to enhance the models using prompt engineering and additional filters to address these issues. This paper introduced TestGen-LLM, which has been successfully deployed in production at Meta. The evolution of TestGen-LLM is detailed, starting from a proof of concept, progressing to a minimal viable product, and finally becoming a deployed test support tool. A key characteristic of TestGen-LLM is its method of guarding against large language model, LLM, hallucination by submitting only those test cases that are guaranteed to improve the existing code base for human review. This is believed to be the first report of assured large language model software engineering deployed at scale in industry. The authors acknowledge the significant contributions of the AI and developer infrastructure teams at Meta, the support from Instagram and Facebook platform organizations, and the valuable feedback from meta engineers who reviewed the code produced by TestGen-LLM. Thank you for watching.